of Science Physics, and I'm Mrs. Bolvin, and today we're going to go over the acceleration problems for practice. Okay, so let's get right to it here. So, actually I'm going to adjust my camera, don't freak out. Oh, maybe too much. Okay, now we straighten the paper and we'll be all good to go. So let's do the first one, calculate the acceleration. So following the 5-part problem solving method, we have acceleration, and we don't know what that is. Calculate the acceleration of a car that can go from rest to 25 meters per second. So meters per second is a velocity, and since it's starting at rest, that number is going to represent the change in velocity. And so change in velocity is 25 meters per second. And it says that and it does that in 10 seconds. So time equals 10 seconds. And it says the car is traveling south. So velocity is one of the things that is a vector quantity there. So we can throw that direction right on there. So our formula, we need something with A, change in V, and T in it. And look right there, there's one waiting for us. So A equals change in V over T. If you're doing this in Google Docs, you don't necessarily need to put this in here. Just realize that it's the change in velocity, not just the velocity at a particular time. So because this one is going from rest to this velocity, that represents the change in velocity. So because that is a hot mess trying to get that in Google Docs. So let's substitute in here. So we get A equals 25 divided by the time, which is 10, and that comes out to be 2.5, and our unit for acceleration is meters per second squared, and because acceleration contains a vector quantity, it must also be a vector, so we need a direction on there, and our direction is going to be south. Awesome. Okay, next one, number 2. Let me see if I can autofocus that a little bit. Sorry if I'm playing with your little brains. Whoop, there it is. So we need to calculate the instantaneous velocity, so we're looking for velocity of a horseshoe that falls freely from a rest position and accelerates. So the acceleration is 9.81 meters per second squared. And what's the direction on that falling horseshoe? Well, if it's falling, usually that means it's falling downward. And the time that it falls is 2.5 seconds. So time equals 2.5 seconds. So we're going to use our acceleration formula. Acceleration equals V, change in V over T. So we have 9.81 equals V over 2.5. So we're going to do that easy peasy shortcut thing that I showed you. So we're going to multiply these two together. So we end up with V equals these two things multiplied together. 9.81 times 2.5. And when you do the math out, you get 24.525. But because we need to round it the second non-zero number, we're going to hack that off and round that up because it's 5 or greater. So the answer is actually 24.53. And we're looking for a velocity, so that's in meters per second. But we need one more thing because it is a velocity. We need to put a direction on there, so the direction would be down because it's falling. Okay, next, number 3, we have a skillet filled with sautéed portobello mushrooms. It's pushed from rest with an acceleration of 3.7 meters per second squared to the right. After 1.8 seconds, that's a time. What is its instantaneous velocity? So we're looking for the velocity after 1.8 seconds. So same formula. So 3.7 equals, V is what we're looking for, and T is 1.8. So again, we're going to do that little trick that I taught you, cross multiplying here. So you end up with V equals 3.7 times 1.8. And when you do that, now don't be scared, because it comes out to be 6.66. I know, sign of the devil, whatever. Meters per second, and because we're looking for a velocity, we need to have a direction on that, and that direction would be right, because that's the direction that was given to us. Okay, 3 down, 2 more to go. So Sophie kicks her soccer ball off the goal line on the football field. If the ball accelerates at 4 meters per second squared forward, what is the speed? And in this case, speed and velocity are the same thing. So that's what we're looking for after 3.2 seconds. So time equals 3.2 seconds. Great. So same formula. Plug into that formula. So acceleration is 4 equals the velocity, which is what we're looking for, divided by 3.2. Again, cross multiply, put the 1 underneath there, and cross multiply your little heart out. So you end up with V equals 4 times 3.2. 3.2 times 4 is 12.8. And we're looking for a velocity, so that's meters per second. And the direction, because it's a velocity, oh, actually, we're only looking for the speed. So because we're only looking for speed, we don't need a direction on this, because speed is a scalar quantity. The last problem, Mrs. Bolvin's training her pet armadillo, Sheldon, to race a 50-meter dash. So that's a distance. And his fastest time to complete the course is 15 seconds, so that's a time. And Mrs. Bolvin, of course, uses a radar gun to find his velocity is 5 meters per second east. So velocity equals 5 meters per second east at the end of the race. If Sheldon started from rest, what's Sheldon's acceleration? So we're looking for acceleration. Now, we know that we need acceleration. Looking back at our formulas here, do we have any formula that has acceleration and distance in it? The answer to that question would be definitely no. So you don't need that little piece of information. So just because it's in a problem doesn't necessarily mean that you need it, because you got to look at what you're looking for and find a formula for that. So the formula you would need is A equals V over T. So A equals 5 divided by 15, and that's pretty easy, 0.333, and we're going to chop that off right there, so 0.33. And the unit for acceleration is meters per second squared, and if you want to know how to make that little superscript, which is kind of important, otherwise it looks like S times 2, before you type the superscript, you in Google Docs you use command, which is the clover leaf thing, and the period. So it's to do superscript, it's command and then period, and that will give you the superscript. And then after you're done with the superscript, you can do those 2 keys again, and it will put you back to normal. So his acceleration, that's his acceleration, but because acceleration is in fact a vector quantity, we need to put in a direction on it. So we're going to throw east on there, because that's the direction we were given. Okay, so hopefully that helps to explain some of these problems to you. Thanks for joining me. Have a great day.